ஸோ இன்றைக்கி கிளாஸில் சம் ஆஃப் த டவுட் செக்ஷன் தான் இன்றைக்கி பார்க்க போகிறோம். ஸோ தென் Unit-2 தென் தெர்மல் ஃபிசிக்ஸில் டெஸ்ட் நம்பரில் 2ல் சம் ஆஃப் த கொஷின்ஸ் வந்து டவுட் இருக்குன்னு சொல்லியிருந்தீங்க. ஸோ அதை பற்றி தான் இன்றைக்கி நம்ம டிஸ்கஸ் பண்ண போகிறோம். ஓகேங்களா? ஸோ தென் கொஷின் நம்பர் 1, this is the direct formula. ஓகே, தென் average energy per degree of freedom according to equipotential theorem. So how to define the equipotential theorem? Then every independent most important quadratic degree of freedom possess an average energy which is called as 1/2. so இதே per degree of freedom questionல வந்துச்சுன்னா here we see that per degree of freedom அப்போ we have to choose 1/2 kT. இதே energy per molecules, இதே per degree of molecule பதில் per molecules அப்படின்னு வந்துச்சுன்னா we have to choose 3/2 kT. okay, this one you have to remember those 2 points. okay, so per degree of freedom or 1 degree of freedom vanda we have to choose 1/2 kT. if it is per molecule keta we have to choose 3/2, or sometimes energy per degree of freedom 1/2 kT, then energy per molecules na then 3/2 kT. okay, here some of the students make those confusion. okay, you have to clear that. okay, so then what is meant by degree of freedom? So then degree of freedom means we can move the motion along x axis and y axis, z axis, then independent wave in which a molecule can store the energy. okay, okay, so this is the most important. okay, so அதாவது ஈக்குபோட்டேஷன் தியரம் என்ன சொல்லுதுன்னா பார்த்தீங்கன்னா, அதாவது ஒவ்வொரு குவாட்ரேட்டிக் டிகிரி ஆஃப் ஃப்ரீடம்க்கும் அதோட சராசரி ஆற்றல் எவ்வளோ இருக்குன்னு பார்த்தீங்கன்னா 1/2 kT, that is per degree of freedom 1/2 kT. energy per molecules na 3/2 kT. you have to remember that. okay, so next one, this is the one of the depth one. okay, this is the concept. The factor 1/3 in the pressure expression arise from, so we know that the formula, what is the formula? Pressure of an ideal gas, then P is equal to, then P represented as pressure, 1/3 the density, then C square is the velocity. okay, here the factor 1/3 which is arise from those cases. okay, we know that then C is the velocity, we have to choose then 3 velocity component, because then 1/3 appears because the molecular velocity is distributed equally in x direction, y direction and z direction. okay, so if C square is equal to, by using Pythagoras theorem, then C x square plus C y square plus C z square. so if you take x, y, z, so in all the 3 axes the molecular velocity will be equally distributed. Apo then C x square, then C y square, then C z square, we have to take it as a Appa then C square is equal to, here C x square a, then C y square a, then C z square a, then C square is equal to 3a. okay, அப்போ then 3 இந்த பக்கம் நியூமரேட்டர் கொண்டு வந்துடலாம். அப்போ then 1/3 then C square by a. okay, அப்போ what is the a? a is here. அப்போ then 1/3 C square, which is equal to, which one is what is that? a represented as, so that is cx square which is equal to then cy square which is equal to cz square. Okay, so then all the direction are equally probable. So the factor 1 by 3 comes from 3 velocity component, cx square x1, then cy square y, then cz square z. Okay, so option B is correct, 3 velocity component. Okay, you have to remember. Okay, this is concept wise you have to understand. Okay, so I already நம்ம teach பண்ணும்போது நம்ம நோட்ல பாக்ஸ் போட்டு சொல்லியிருப்போம். Okay, so you have to remember this one. Okay, so next one, then choose wrong one. This is the most important. You have to choose wrong from the 4 option. Then equipartition theorem fails at. So equipartition theorem எப்போ ஃபெயில் ஆகும்னு கேட்டிருக்காங்க. ஓகே, ஸோ தென் equipartition theorem பார்த்தீங்கனாலே that should be a equipartition theorem எதை அடிப்படையில் உருவாக்கப்பட்டதுன்னு பார்த்தீங்கன்னா கிளாசிக்கல் மெக்கானிக்ஸ். ஓகே, ஸோ கிளாசிக்கல் மெக்கானிக்ஸில் தான் equipartition theorem அடிப்படையினால் உருவாக்கப்பட்டது. ஓகேவா? So the equipartition theorem is a classical theory. Okay, but classical theory la எப்பவுமே வந்து very low temperature ல நம்மளால கனெக்ட் பண்ணவே முடியாது. So then we move on to the quantum effect. Okay, we move on to quantum effect became important. Okay, so because some degree of freedom became free side. Okay, so the energy is not equally shared, so that's why the equipartition theorem fails. So the equipartition fails at very low temperature. Option A is correct. Okay, so then temperature குறையும் போது என்னாகும், குவாண்டம் எஃபெக்ட் அதிகமாகும். ஸோ அப்போது அந்த சமயத்தில் என்ன பண்ணணும்னா சில டிகிரி ஆஃப் ஃப்ரீடம் வந்து நம்மளால் செயல்படுத்த முடியாது. ஸோ அதன் காரணமாக நம்ம என்ன பண்ணுவோம், சில டிகிரி ஆஃப் ஃப்ரீடம் வந்து ஃப்ரீஸ் ஆகிடும். ஓகே, ஸோ அதனால தான் என்ன பண்ணுவாங்க, ஈக்குவபார்ட்டிஷன் தியரம் லோ டெம்பரேச்சரில் பொருந்தாது. ஓகே, இஃப் இட் இஸ் low temperature only for quantum effect. Okay, very low temperature it is not suitable for classical one. Okay, so this is the reason the equipartition fails at very low temperature. Okay, so the next one, here also we have to choose a wrong one. Okay, so for Maxwell distribution, then area under curve which is right, then peak decreases with temperature, this also right, then curve shift right with temperature, this is also right. We have to choose wrong one. Then for Maxwell distribution, this one is wrong, all speed are equal, that should be a never. So then all molecules will move in different speed. Okay, so all speeds are equal will be a wrong. For example, you know very well Maxwell distribution curve. Okay, so if you take the Maxwell distribution curve, this is curve, then another curve, then another curve. Okay, if you take, this is the temperature 200 Kelvin, this is temperature 400 Kelvin, this is temperature 500 Kelvin. If you see that when the temperature is increases, the peak will be lower, and at same times there will be a broad, that is important. So here we have to see, so definitely molecule போகும்போது அங்கே என்ன ஆகும், the speed will be a varied, அப்போ the probability கண்டிப்பாக அங்கே இருக்கும். So the area under the curve which is equal to 1, then peak வந்து when the temperature is increases, the peak will be decreases. Okay, so then curve shift right with temperature, when the temperature is increases, the curve shift towards the right. Okay, so all speed are equal, it's a not equal, it should be a different. So option D is wrong. Okay, so this is the most important, you have to remember. So the next one is a numerical problem. If mass double, then most probable speed, we know that the most probable speed, what is the formula, then 2 kt by m. Most probable is proportional to 1 by root m. So if the mass is increases, then speed is decreases. Here double the mass, vmp most probable, which is equal to then 1 by mass is the double, then root 2. Which one is correct? The correct option is became 1 by 2 times. Option C is correct. Okay, so this is the most important. So next, match the following. So this is the list 1 and list 2. So here from the list 1 we have to give then translation, rotational for linear and rotational for non-linear, and vibrational mode energy. Okay, so what is meant by rotational? So then rotational degree of freedom is 3. For rotational degree of freedom for linear 2, only diatomic molecules according linear. For rotational degree of freedom for non-linear, it should be a 3 axis, along 3 axis there should be a 3. Then vibration mode of potential energy and kinetic energy, then we have to get kt. Okay, so option, which one is correct? Option AK 1. Which one is correct here? 1 ku A, then 2 ku B, then 3 ku B, then 4 ku D. Option A is correct. So this is the most important. Kandipa problem varum. Okay, so then translation we have to rotate 3 axis x, y, z. For rotational for linear, only we have to rotate 2 axis because of diatomic molecules x and y. So the rotational non-linear, we have to rotate about 3 axis x, y, z. Then vibrational mode, that should be a quadratic degree of freedom. Then potential and kinetic energy, both are 1 by 2 kt. We have to total energy, then we have to get kt. Okay, so this is most important. Okay, so next one is another one is also the numerical problem. What is the ratio of average and most probable speed? What is the formula for average speed? Then root 8 kt by pi m. Then what is the most probable speed? Then root 2 kt by m. We have to take ratio, then root 8 kt by pi m divided by then root 2 kt by m, which is equal to then root 8 kt by pi m into m by 2 kt. Okay, then we have to cancel m, then kt cancelled, then we have to cancel out 2 4, which is equal to then root 4 by pi. So answer C is right, or we have to write it as 2 by pi. Okay, so option either go, we have to choose that. Okay, so option C is correct. Okay, so this is also one of the important, that should be a concept wise. Okay, for non-linear molecules, the total degree of freedom including vibration, that is the most important. Okay, so what is the total degree of freedom? The total degree of freedom. So what is the translation? Already we have to discuss from the previous case, that should be a 3. For rotational for non-linear 3. For vibrational, here we have to ask including vibration. Then vibrational, then 3n minus 6. We have to add everything, then 3 plus 3 plus 3n minus 6 3 plus 3, then 6 plus 3n minus 6, we have to cancel out, then we have to get, then total degree of freedom is equal to 3n. So option A is correct. Okay, so this one already discussed from the previous question. Okay, then Maxwell area curve is always unity. Definitely there should be a probability occur. Okay, so then high temperature effect, so when the temperature is increases, we have to get broader curve. Already we have to discuss from the previous question. Most probable speed is the peak point, highest peak point. Then root mean speed is the highest value. Okay, highest value already we have to discuss. Then most probable is lesser than V average lesser than RMS speed. So RMS speed is the highest value. Okay, so option, which one is option A is correct. Okay, so question number 38. So the next question, choose the correct one. Okay, at high temperature the vibrational degree of freedom contribute. So then each vibration mode consists of two quadratic energy term. Two quadratic energy term. First one is kinetic energy and second one is potential energy. Okay, so then each quadratic term contribute 1 by 2 kt 1 by 2 kt. Apo then total vibrational energy per mode, which is equal to 1 by 2 kt plus 1 by 2 kt, we have to add, we have to get kt. Option A is correct. Okay, so this is the important one. Okay, then each vibrational mode then consists of two quadratic energy term. Okay, so one is kinetic energy, another one is a potential energy. So according to the equipotential theorem, we have to define what is meant by equipotential theorem in question number 1 itself. So then each quadratic term contribute 1 by 2 kt. So kinetic energy and potential energy, then we have to get, then we have to add, then we have to get kt. So option A is correct. Okay, so next one is choose the wrong one. Okay, that is the important. சில சமயம் கரெக்டான ஆன்சர் சூஸ் பண்ணுவாங்க, but here the question will be asked is we have to choose only the wrong. Then Maxwell distribution predicts, so already we have to discuss through, we have to draw the graph from the previous one. See here which one is wrong? All molecules have same speed, that should be a wrong one. All the molecules will move in different speed. Okay, சில molecules slow-ஆ போகும், சில molecule average-ஆ போகும், சில molecules fast-ஆ போகும். Oh, so then first one is wrong. So then continuously speed range, it should be a kind, then most probable speed exists, then temperature dependent case. So option A is correct. Okay, so these are all the question we have to discuss from Unit-2 thermal physics. Okay, from UGTRB. Okay, if you have any doubt, we have to ask your doubts or question through WhatsApp. Okay, then we have to make the video YouTube, or we have to put the live classes through the app. Okay, so we have to discuss in the similar question pattern in next classes. Okay, thank you.